Hello, everyone. We're going to talk about section 2.4 on chemical formulas. Once again, I'm going to be sort of moving through the textbook here because there are a few things that we are not going to get into as much detail on as you might think if you were to just read the textbook. So let's start with the learning objectives. So by the end of this section, you will be able to symbolize the composition of molecules using molecular formulas and empirical formulas, and then represent the bonding arrangement of atoms within molecules using structural formulas. I'll just preface this by saying the first one there is probably more important than the second one. I'm going to actually go ahead and use the blue there to show that that one's maybe a little bit less important. We want to recognize a few things there, but not to the detail that your textbook is discussing. So we've talked a little bit about molecules already and about chemical formulas already. Now we're going to look at a few ways in which these can be represented. So a molecular formula is something we've essentially already seen. It's a representation of molecule based on just showing the chemical symbols and subscripts indicating how many of them you have. So when we talk about, for example, H2O, that is the molecular formula for water. We also have what is called a structural formula. It has the same information that you would have in a molecular formula, but has additional information as well by showing exactly how the atoms are connected within the molecule. So here we have some examples of molecular and structural formulas. So this is a molecular formula. It's showing that we have a molecule that contains carbon and 4 hydrogens. So we're showing the symbol for carbon, the symbol for hydrogen, and then the subscript 4 is telling us that we have 4 of the element before that, which is the hydrogen. We don't have 4 carbons, we only have 4 of the hydrogens. This is the molecular formula. The structural formula is showing us not just that we have these 5 particular atoms within the molecule, but how they are connected together. So we're showing that here for the same molecule. So this is methane. And just to let you know, you don't have to memorize that this is methane. We're just using it as an example. We'll be getting into naming molecules very shortly, but not something you need to know right now. So what we're showing here is that the way that these are connected is we have carbon with some kind of a connection or bond to 4 different hydrogen atoms, and that's how it's connected. You might imagine other ways that it could have been connected with this formula or not. You may not have thought about the connection at all, but the structural formula is showing the specific way in which those connections are made. We have other ways of showing additional information through artwork, right? So again, not an art class, so you don't have to be able to draw these things, but these are additional representations that actually contain even more information. We're not showing the, I guess, the angles of how these bonds are relative to each other within the structural formula. But within the ball and stick or space filling model, we are showing that information. Again, you don't have to know any of that right now. These are things we'll cover much later in the semester. Just be aware that we have this is a molecular formula, this is a structural formula, and then these are additional ways of representing that have information about geometric arrangements that we don't care about yet, but we'll care about by the end of the semester. Some elements do exist as molecules. We talked about that a little bit earlier. And here we're showing sulfur as a molecule. In this particular case, has 8 sulfurs involved in 1 molecule. So this is a structural formula for that. This is the molecular formula, and then these would be balance or space balanced and space filling models for the same thing. In terms of these elements that exist as molecules, we do have some that are important that are called diatomic molecules. So let me just go ahead and highlight that. So these ones are probably important to know. So I'm going to go ahead and highlight them. So the diatomic molecules are hydrogen, oxygen, nitrogen, fluorine, chlorine, bromine, and iodine. And what they have in common is they are elements that exist as molecules where you have two atoms of the same element present. And why it's a little bit important to know these is you might have a question that says something about oxygen or something about hydrogen, and you would just need to know that when it says oxygen, that means O2, hydrogen means H2, etc. So just be aware of that. We'll come back when we talk about the periodic table and probably reemphasize this a little bit because it's there's an easy way to kind of remember those using the periodic table. So a few things I want to mention here, and your book does a great job in this figure of highlighting this, is when we talk about atoms and molecules, and we've hinted at this in a previous section, what do we mean by that? So if we say H, we mean one H atom by itself. If we say 2H, we mean two hydrogen atoms, each one separate from the other, so two separate things. When we say H2, though, we mean something different. We mean that those hydrogens are acting together as a molecule. So that is one H2 molecule. So hopefully you can see the difference between 2H and H2. This is a difference that will become important as we start to look at chemical reactions in the next module. And then we could even have a case where we have multiple molecules. So we're showing an example here of that, of two hydrogen molecules. So be aware of that difference between the placement of the numbers and what that means about molecules or atoms and how we might represent those. Here symbolically, what that would mean if we were to represent that kind of on the molecular level in terms of showing them in the way we're showing them here. Okay, so I want to talk about something a little bit different than a molecular formula. That's called an empirical formula. And empirical formulas will be important, and we'll see in a later section why sometimes we need to talk about empirical formula instead of molecular formula. An empirical formula is the simplest whole number ratio of the number of atoms in the compound. Okay, so that's the definition of that. So it's not saying exactly how many you have, but it's saying what the ratio is of the ones that you do have. As an example, we're looking at TiO2, and we're showing it here. And so this is used as a sunscreen. And you'll notice that there are lots of things here. In fact, there's probably more than what we're showing. So writing the entire formula, if we were to write a molecular formula, in fact, as we'll learn later, molecular formula is not even a good word for what we would have here. We would have a lot of them, but overall within this compound, we have a ratio of 1 titanium to 2 oxygen. So when we write it like this, we call that an empirical formula because there might be more than just 3 atoms involved, but the ratio of all of them will have be what you show in the empirical formula. An example of where that might differ from a molecular compound is shown here. And so this is the molecule benzene. Again, you don't have to remember these examples right now. This is the empirical formula of benzene. Let me go ahead and highlight that so we can see that. So this is the empirical formula. The molecular formula, actually we're not showing the, oh, here it is right here, is right here, okay? So this is, actually, let me go ahead and highlight this whole thing. Molecular formula of benzene is C6H6, okay? So empirical formula CH, molecular formula C6H6. So you can hopefully see, if you were to see that this is the molecular formula, that the empirical formula you would divide by 6 to get to that. Here we're also showing structural and formula, and then ball and stick and space filling models for it. Again, you don't have to know from this that you would have this. Don't worry about that. You would just need to recognize that this is a structural formula, this is the molecular formula, and this is the empirical formula. Here we're looking at an example of another molecule where we might be able to see a difference between the empirical formula and the molecular formula. So this is vinegar. This is the molecular formula of vinegar, and you'll notice you have C2H4O2. Each one of those can be divided by 2, and if we do that, we end up with CH2O. Okay, so this is, again, molecular formula, empirical formula. And then we can, again, show structural formula. You don't have to know how to figure that out, but you would want to recognize it as being a structural formula. So there's a few examples here of how you would go about determining the empirical formula if you knew what the molecular formula was. And then I wanted to just briefly talk about the last bit here, but it's not something you'll have to know a lot of detail on. And that is the idea of isomers. So isomers have the same chemical formula, but they have a different molecular structure. So we're showing an example here. We're showing this is the molecular formula for this, again, acetic acid is vinegar. This is, I should say, the main component of vinegar other than water. So we're showing C2H4O2 is the molecular formula for that, but it is also the molecular formula of something called methyl formate. So they have the same molecular formula, but they have different structural formulas. So it is possible to have even different molecules when you have the same exact molecular formula. Now, that level of detail is something we won't get into in this course, but if you go on to take organic chemistry, that's a big part of organic chemistry. And in terms of different ways for that to happen, we're looking at some examples down here of structural isomers and what those might be. So again, don't worry about this detail at the end of the section. That's something that you'll cover in more detail in a organic chemistry course if that is something you end up taking. So that is it for section 2.4. Feel free to move on to section 2.5.